I am going to try using the t results. So what should be my first line? Let t equal tan x on 2. Kind of an important line, okay? It's even more important than you think it is. Alright, so if that's the case, I'm going to go straight into my substitution now, okay? This is going to be 2t. This is going to be 1 minus t squared. That's equal to 1. By the way, just a quick note, it is absolutely critical, even though you're going to start to get a little more comfortable with this, you should never, ever write the first line with your 1 plus t squared on this side. You're like, oh, of course I'm going to multiply through, right? You will always multiply through, but you're not doing the substitution, okay? You're not showing that I know what the t results are for sine and cosine. So this line is critical, okay? After you get that line, knock yourself out, right? Which is exactly what we're going to do. I got my 2t minus 1 plus t squared. Yep. 1 plus t squared there. So far so good. Okay. So you start to think, okay, I'm going to cancel some things here. I've got t squared on both sides. Now normally I would move everything over to the left hand side, but because I don't have any more t squareds, I'm going to leave that 2t on the left hand side by itself and move this guy over that side, leaving me with a 2. So far so good?
Yeah.
So t is equal to 1, but remember, t is in fact tan of x on 2. So, remember, there is some angle that when you take tan of that, you'll get 1. Tan of 45 degrees. X on 2 equals 45. Just like before, I'm in this domain when I'm solving functions in terms of x on 2. So normally, if I saw tan of something equals 1, I would normally say, there's one solution, and then I'll get my next one 180 degrees later at 225. But I'm not in that domain, because I'm in terms of x on 2. So that's it, okay? So then I say x equals 90, and then raise my eyebrow? Now what's going on, okay? Something's gone wrong, and there's a few ways to know, okay? For starters, like I showed you a question before, right? They looked almost exactly like this. I just slightly adjusted the coefficients, okay? Now, I didn't adjust them that much. We got 2 solutions before. I ought to kind of expect 2 solutions here, right? There's something else that's a bit sus, right? We started with a quadratic. Things were fine. But then the quadratic just kind of disappeared, right? That's why we went from 2 solutions to 1. Okay. Now you can be doubly sure because this guy up here, right? Remember, I always encourage you as much as possible to think in terms of visuals, right? So solving this, do you agree, is saying like this is a graph, sine x minus cos x. It's a graph, and it's going to go like that. And when's it equal to 1, right? Now it's a bit hard to picture because you guys haven't done many graphs like this. You will, right? So let me give you one that will be a little bit easier to visualize. See this guy? I'm going to kick him over the other side. Do you agree that our original question and this red line, this red equation, they should have the same equations, right? The same solutions, rather. Make sense? Now, this is really easy to visualize. We all know what this looks like, okay? Let's do sine. That's nice and easy. There's sine. What's the range of sine?
1 to 1.
Minus 1 to 1. Mathematicians read things in ascending order, okay? I've got 1 plus cos x on the right hand side. What's the range of 1 plus cos x?
0 to 2.
It's this range moved up, right? Plus 1. So it's 0 to 2, isn't it? So if there's 0 and here's 2, so it's just the regular old cosine thing, but it's all been raised up. Okay? So I'm getting this kind of shape. Oh, I missed. You get the idea. Okay, now sure enough, as we kind of were anticipating, there's one solution, surprise, surprise, 90 degrees. And then there's another solution, right there. What's that angle?
180.
That's 180. 180. 180. Sine of 180 is equal to?
Negative 0. 1. What?
0.
0.
Cos of 180 is equal to negative 1. So minus negative 1
Is positive 1.
is 1. 180 is a solution. So why did it disappear?
Because you divided by
Is it because we're using tan?
Okay, all right. Remember I said, what's the first line? Right, and I made a big deal out of it. And some of you were like, oh, whoops, I forgot to write the first line. The first line is critical, but this is not the first line. That's not what the first line should be. Because tan, picture it in your head, right? From 0 to 360, right? What's it look like? Well, it's got a couple of these guys hanging around, doesn't it? Right? And then it looks like this and this. See it? Okay, so where does it exist and where does it not exist? Okay, I can see it has asymptotes at x equals 90 and x equals to 70. See? Right? So x can't be equal to 90, really? Like, it doesn't work. You put it into tan, it just blows up. Now that's tan x. But I'm dealing with tan of x on 2, right? So in fact, if I put in, not 90, right? But if I put in 180 degrees, what happens here? Tan of 180 on 2 is tan 90. It explodes. There's no solution there, right? This thing will not have solutions at 180 degrees, right? But that's completely foreign to the question. We introduced this T business, right? This question has no tans in it. It shouldn't have this problem, right? And sure enough, when we graphed it, it didn't. It has a solution at those points, okay? So here's what we were missing, and this is what your 4 lines were for, and we'll put it on both of these, okay? You arrive at the end, right? If you use T results, you must, every single time, check if this is a solution, right? Because you've artificially removed it from the question, right? So you have to say, test x equals 180 degrees, right? Yeah.
Does 180 not come up because T formulas originate from the right angle triangle?
Aha.
180 is like...
Okay, another way to make sense of it, right? Yeah, things break down because we've introduced this extra structure, which makes it easier to solve, but in the process, it removes things, okay? So I'm going to test it. Here's the way I do it. I'd say left-hand side equals, and then I'm literally going to put the numbers in, right? I'm going to go sine of 180. We did this about 2 minutes ago. Minus cos of 180. Okay, sine 180 is 0, minus cos of 180 is negative 1, and sure enough, that's 1, which is the right-hand side. So therefore, 180 degrees is a solution. It satisfies the original question. Yeah?
Does this appear with anything else, like 270? No, not 270. Like, does it appear further on?
Okay, so the answer is yes, because, tan is periodic. However, because of the domain you're actually interested in practice, this is really all you're ever going to have to worry about. Okay? So yeah, but that's worth noting for. X equals 180, that's a solution. So therefore, x is equal to 90 degrees or 180. Okay? So this is kind of like the Achilles heel of the T results for this. Okay? You will notice it, by the way. It should do this. You shouldn't just be blindly always testing it. Right? There will be things that cancel, and you'll be like, what happened to my other solution? It just sort of disappeared, right? Now, even if that doesn't happen, which is what happened here, we've got 2 solutions, and that's actually correct, right? You still have to test, right? You still have to show this. So this is what those 4 lines are for. You'd say, test x equals 180 degrees, right? Now the question we started with was, what was it, 3 sine x?
Yeah.
3 sine 180 degrees minus 2 cos 180 degrees. Okay? This is not hard to evaluate. It's not like, oh man, the T result sucks. I add all this extra work. This part here is trivial. The hardest part is just remembering to do it. Okay? Sine 180, we already said that's 0. That's minus 2. Cos 180, we already said that was minus 1. So you get 2, which is not equal to the right-hand side. So, no problems. 180 is not a solution. And we've already found the 2, they're there. Okay? Yeah.
Is there like a mark allocated to this in the test?
Yes. Okay. So if you are given a question and T results are the only way, excuse me, to solve it, which is uncommon, but admittedly, then there will be a mark devoted to that. For a question like this, I wouldn't be surprised if it was, well, if it was this question, it'd be 3 marks. It'd be 3 marks. The first mark would be on actually doing the substitution and getting the right algebra there. Second mark would be for the solution. Third mark would be for the tests, which gets you the other solution, right? Here, again, 3 marks. Your first 2 marks will be to get to these solutions through the algebra, and your last mark is for testing and showing that x equals 180 isn't done. Okay?